Hello friends, welcome back to our channel. Today in part 2.3 of Mastering Parallel Programming series, we are diving into the concept of functional purity in C PLINQ. In this video, I'll break down the concept into simple terms and provide you with a clear understanding. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you'll be notified every time I upload a new video. Okay, without any further delay, let's get started. PLINQ in C Sharp. If you watched my previous video on Mastering Parallel Programming series, you might recall this diagram. Well, today we will go ahead one more step further and learn the concept of functional purity in PLINQ. Understanding functional purity in PLINQ. What is functional purity? In PLINQ, functional purity in simple terms refers to writing code in a way that functions don't have side effects. But what exactly are the side effects? Well, imagine you have a function, and when you call that function, it changes something outside of itself, like modifying a variable or writing to a file. So these changes are considered side effects. Okay, so let's understand this concept with an example in C Sharp. So here we have a query that multiplies each element of a range by its position. So take a look code snippet. So here example number 1, where I am showing PLINQ query without functional purity. What I have written, int position is equal to 0. Then I have written one PLINQ query, where query is equal to from an innumerable dot range 0 to 5 dot edge parallel select n multiply by position plus plus. So here in this example, what I am doing, the query is trying to achieve a specific task, but it using the variable position which is placed outside of the query to keep track of the position. And to make matter worse, position is being modified with each iteration, because we have written position plus plus over here, right? So which is a classic example of a side effect that we don't want. What is the solution for that? So here I am showing the another example, making the PLINQ query functionally pure. So here what I have done, I have written this query where query is equal to enumerable dot range 0 to 5 dot edge parallel dot select. Here I am mentioning n comma position goes to n into position. So to make the code functionally pure, we need to avoid side effects like modifying position. So instead, we can use the index version of the select method, which takes both elements n and its index position, right? That's what I have written here, select n comma position. So in this rewritten code, we have eliminated the need to modify any external variables like position over here, right? And making the code functionally pure. This simple adjustment enhances the clarity and readability of our code. Okay, so let's switch to the Visual Studio and see all these things in action. Okay, so here we are in Visual Studio and going to demonstrate the concept of functional purity in C PLINQ by comparing two approaches, without functional purity and with functional purity, and perform a similar operation. To show the demo, what I have done, I have created one console application named functional purity that has program.cs. In program.cs file, first of all, I have added necessary namespace. We have added using system for basic functionality, system.linkQ for linkQ operation, using system.threading.task for task-based asynchronous program. Then there is a class named program that has a static int variable named position, and I have initialized with 0 to it. So this variable will be used to track the position within the sequence that we will be seeing in the later part of the. Then there is a main method that serves as an entry point of this program. Here what I am doing, I am just printing a message demo of functional purity in C PLINQ that basically indicates that it's a demonstration of the functional purity. Then what I am doing, I am just calling these two methods. Call me to show the result without functional, call me to show the result with functional purity. Okay, let's understand this call me to show the result without function purity method. This is nothing but the static method and return nothing. That's what I have written required as a return. So this method demonstrate an approach without function. So here what I have done, I have written one PLINQ query to generate a sequence of numbers using enumerable.range 0 to 5. So here each number is multiplied by the current value of the variable position, and the position is post increment. That's what I have written, select and multiplied by position plus plus. And then I have written this statement result without functional purity. Then what I am doing, I am just using this for each loop and print the result that we are retrieving from this query result set, right? And then finally I'm just printing this position variable value also. I reset the position variable. That's what this method is doing. So here I have not used functional purity at all. Now let's see this call me to show the result with functional purity method. This is also a static method and return nothing. That's what I have written the void as a return type. Here I am just making the code functionally pure. What I have done over here, I have written this query where query enumerable dot range 0 comma 5 dot edge parallel dot select n comma position goes to n multiplied by position. I have written one parallel query using PLINQ, but instead of using a variable for position tracking, it utilized the index version of the select method. So in this index version, each element n of the sequence is paired with its index position. That's what I have written, select n comma position. And the lambda expression n multiplied by position, it basically calculates the result based on the element and its index. Finally, I'm just printing this statement result with functional purity. Then I'm iterating with the help of for each and printing the results of the query into the console. Printing this position variable also, because here this position variable is nothing related to the index position that I have given as a variable name over here. Basically, this position is pointing to the static global variable that I have mentioned over here, right? So right now it should be printed as a 0 because I have not used this position variable at all. Instead of that, I have used the index position of the select method. Okay, so that's all this program is. Let me execute this program and witness the output. Okay, so output got appear into console window. See the statement demo of functional purity in C# PLINQ got printed. Then result got printed without functional purities. 1, 4, 9, 16. And if you notice, position variable value got printed as 5 because code was written without functional purity and utilized as a tracker for position sequence. And that's the side effect, and that we should avoid for maintaining the code and predictable outcome. Okay, so then result with functional purity got printed. And we wrote the PLINQ query in functionally pure way that avoid the side effect. That's why if you see the position variable value, it remains unchanged and is still 0, right? So that's all about the functional purity. Okay, so that brings me to end of my session. To sum up, we learned today what functional purity is and how it ensures that function produce the same output for the same input and avoid side effects, leading to more predictable and maintainable code. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.